together here. Alright, so how do we find the value of h and k and a if we're given the graph only? Well, for that we need to know what the original graph looks like and then compare and contrast the two. So transformation reminders. The original graph is located with the vertex 0, 0, and increases at a rate of 1 over 1 in both directions. And I should say increases or decreases. Okay, so a sample little graph here would be, here's the vertex, it's increasing and decreasing at a rate of 1 over 1. Okay, there's my original graph. If the graph shifts right, then h is positive. If it shifts left, h is negative. And the example there is that's the h we're talking about. Okay, so if it doesn't look like this and it looks like it shifted to the left or to the right, then that's the h value that was affecting it. If the graph shifts up or down, the up means the k is positive, and the down, the k is negative. So the example there would be x minus h plus or minus that k value. Okay. Now I do show you some steps to write the equation of a graph, but you should be able to look at a graph and tell me approximately what the function should be without having to do all of this work. Okay, but we're going to do the work here, and then you're going to get more practice with this on Monday. Alright, go ahead and let's draw your graphs, because I actually forgot to draw those in there. Put a point at 3, 4, and then put a point at 6, 6, and one at 0, 6. And then drawing your graph like that. Okay, and I'll write out the steps for example 3, and then you're kind of going to do the same thing for example 4. Notice these are both 4-type problems. Okay, so if you're given the graph, you can see it's an absolute value because it's a V shape. First thing you're going to do is start with the general form, which is y equals a times x minus h plus k. And I should throw out there that with any of the algebra functions that we deal with, when you have to write the equation based on the graph like this, besides lines, you're going to follow this type of format. So the original or the general form is the general form of whatever function you have. So we have an absolute value graph there. We're going to use the absolute value general form. Okay. Then you determine your vertex. These values are your h and k. Then you're going to pick another point on the graph. Use as your x and y. And then our final step here will be to plug in x, y, h, and k to solve for a. Okay, so let's do that over here. My hk is 3, 4. And then I'm going to pick one of these points. Let's do 6, 6. Okay? This is going to be my H, my K, and then any other point on the graph, we're going to label X and Y. We're going to take all 4 of those values and plug them in to my general form. So my Y value is 6. I'm going to be solving for A here. My X value is 6. My H value is 3. My K value is 4. Then we simplify. So 6 minus 3 gives me 4. So that's 6 equals 4A plus 4. And then I'm going to subtract 4 from both sides. And A ends up being 1/2. So the equation of this line, I have my A value and I have my H and my K. When you write your equation, you write it with just H, K, and A plugged in because you want the Y and the X to stay so that it represents every point on your line. Okay? Six. That's not right. Hold on. I missed something. Oh, sorry. That's a 3. That should be, sorry, 2/3. Okay. I'll give you a little hint here, and this only works with absolute value functions. This A value will be the slope, 1, 2, of that line. And since the graph opens up, we know it's positive. Okay, but I'm not going to stress that because it doesn't work for any other function except that. Okay, let's draw another graph. Put a point at -2, 3, and then one at -1, 2, 3, -3, 0, and -1, 0, and draw your graph. Okay, so same thing, except I'm not going to write out the steps again. You determine your vertex. Your vertex is your values for H and K. So we had -2, 3. It's going to be my H and my K. Then you pick another point. So I'm going to pick this point here, which is -1, 0. That's going to be my X and my Y. And then you plug all 4 of those in so that the only variable that you have to solve for is A. So I have 0 plus A times -1. And now we're going to subtract a -2, so I'm adding 2 plus 3. And simplify. -1 plus 2 just gives me 1. A. So A is going to be -3. Notice the slope is down 3 over 1. So your final equation here will be -3. Then parentheses X minus a -2 plus 3. And that would be your equation. Okay. We'll do a few examples of this on Monday, and you'll get a lot of practice on these types. Over and out.